Optimal execution is a myth. The Almgren-Chriss Model, the industry standard, only has a clean solution under unrealistic assumptions. Add random volatility or nonlinear impact, and the HJB equation explodes in complexity. We'll show you why, and how deep learning is stepping in. Let's start with the baseline. The Almgren-Chriss model describes how a trader's orders move the market. The price evolves with a random component and a permanent impact from trading speed. There's also a temporary cost. This framework is the foundation of most execution algorithms. The trader's problem is to choose the trading speed to minimize expected cost. This leads to a Hamilton-Jacobi-Bellman equation, or HJB. It's a partial differential equation that describes the optimal value function. The equation balances the cost of trading now versus the risk of holding inventory. The HJB equation is easy to solve when the model is simple. But add stochastic volatility, jumps, or nonlinear impact, and the state space grows. Now we have time, price, volatility, inventory, and realized cost. That's 5 dimensions. Traditional grid methods become computationally impossible. Deep HJB methods use a neural network to approximate the value function. The network takes the state as input and outputs the value. We train it by minimizing the residual of the HJB equation. This avoids the grid, but it's not without challenges. Deep HJB is promising, but it's not a silver bullet. Training can be unstable, and you need a lot of samples. The loss landscape is complex, and convergence isn't guaranteed. This is an active area of research, and practical implementations are still maturing. Let's compare the classical approach with Deep HJB. Classical methods give exact solutions but only for simple models. Deep HJB can handle complexity but with approximation error and computational cost. The choice depends on the problem at hand. Despite all this math, most real-world execution uses simple heuristics. VWAP and TWAP are common. They don't solve the HJB equation, they just follow a schedule. Why? Because the true optimal strategy is often intractable. So traders rely on rules of thumb and online adjustments. Heuristics work because they are robust. They don't rely on precise model assumptions. They adapt to market conditions. And they are easy to implement. In practice, the cost of a suboptimal schedule is often small compared to the risk of model error. To evaluate any execution strategy, traders look at a few key metrics. Implementation shortfall measures the cost relative to the arrival price. Slippage is the difference between expected and actual price. And volatility captures the risk of holding inventory. The future likely lies in hybrid approaches. Use Deep HJB to get a good starting policy, then fine-tune with heuristics. Or use deep learning to calibrate model parameters in real time. This combines the best of both worlds. We've seen that optimal execution is a mathematical ideal, not a practical reality. The HJB equation is beautiful but often intractable. Deep HJB offers a path forward, but it's not a silver bullet. In practice, traders must balance sophistication with robustness. The key is to understand the assumptions behind any model and to validate it with real data. We'd love to hear your thoughts on the future of execution algorithms. Markets reward discipline, not certainty. If this analysis helped, like the video and subscribe to DeepQuant. Tell us in the comments which market idea we should test next. Evidence beats noise. Control risk before chasing returns.